Welcome to the session on cleaning up external resources. My name is Venkat Subramaniam. In this presentation, we're going to talk about what we have to take care of to clean up external resources. This is part of a series of presentations where we talk about garbage collection at the language level. So let's get started. Suppose we are interested in using an object that needs to use an external resource. How do we deal with the cleanup of the external resource, and not only just cleanup, but just a general maintenance of the external resource itself? So we'll start with an example to understand the consequences of this. Let's say for a minute we have a writer class and we have a constructor of the writer where we're going to create our external resource we are interested in, and we're going to write something to that resource, in this case just a file. So let's get started with a file object. Well, a writer object rather, and in this case the file writer, I need to initialize the writer. So I'm going to say writer is equal to new file writer, and we will give it a sample.txt file name to begin with. So that's the file I'm interested in writing to, but what content am I writing to that particular file? Well, here is the content I'm going to write. So I'm going to say writer.write over here, and the content I'm going to be writing is the message that's been sent to us. So that is what the writer is doing. Now this is a very simple trivial example, but all that this my writer does some work potentially and then write stuff to the particular file writer that we have created. Let's go ahead and use this to see how this is going to work. So I create an object of my writer, and I go to the my writer object and I say write, and let's just say hello for this and write the content of hello to this. So right there we wrote that content. Let's go ahead and run this little code and see what it does. Well, it doesn't produce any output on the console right now, but we can take a look at the file it was supposed to have written. So if I go ahead and look for a sample.txt file, sure enough there is the file sitting on the disk, and I ask him to give me the content of the file, and notice it doesn't have anything here as the file content. Something seems to have gone wrong. Well, in this case we never told the file to be closed, and as a result the content we wrote is sitting in the buffer and has never been written to the disk at this point. So it's our responsibility to make sure this is closed properly. One initial thought that may come to our mind is, should we go ahead and write a finalize method? We discussed about this in the presentation, automatic garbage collection, automatic not instantaneous, but I'm going to go ahead and say writer.close and close the connection to the file itself. Now when I go ahead and run this code this time and go back and look at the output one more time, we notice it is still empty. So what does it tell us? It tells us that the close was either broken or the close was never called. Well, we can trust the close method to be working properly, but the finalize method actually has not been called in this case. So the moral of the story really is we shouldn't really depend on the finalize method if we want something to be done really. So what do we do instead? I'm going to rename this finalize method into a close method, and then within the close method I'm calling the writer.close. Now I can come in here and say writer.close to call the close method itself. So now if we go back and take a look at the file's content, we can see that it's written the content we wrote, which is hello right here. So the problem with finalize is called when the garbage collector decides to garbage collect the object. Garbage collection is related to memory cleanup, but our concern here is external resources. In other words, this is one thing we have learned very clearly in programming. The minute we bring two independent things together, we are in trouble. And this is another example. Automatic garbage collection deals with memory, but we are interested in external resources, and we are trying to combine the two together to say, oh, whenever you're cleaning up the external resources, I want to clean up the memory, or when you're cleaning up the memory, I want to clean up the external resources. These two are independent of each other, and if we try to bring them together, we are in trouble. So this is, we know this already, called the single responsibility principle, and yet we keep failing at it over and over in so many ways and so many places. So we need to close the resource properly, and it is our responsibility to do that, and that's what we are seeing here by writing the close method. Unfortunately though, as effective as this close method has been, we are still in trouble in this particular case. For example, what if there's something went wrong in this code and the code is going to fail? For example, if I say my writer.write and I'm going to call this with a foo, and maybe just as this is a pretty contrived example as you see, but in this case I'm going to say if the message is equals to, let's say, foo, I want to throw new runtime exception, no foo here. And let's go ahead and just run this little code and see what it does. When I run this code, we can see that it blew up as we would expect. Let's go over here and take a look at what's in the file, and you can see that the content is still empty. In other words, the content we wrote so far in here doesn't really seem to exist in the file. So in order to tackle this properly, it is our responsibility to make sure that we close the resource or clean up external resources when there is an exception also. So I'm going to go ahead and put a try block around here. I'm not interested in catching the exception in this code. Potentially it could be caught at a higher level of abstraction in a typical application, but I'm going to simply put the word finally here and tell that within this finally block, I'm going to do the close. So the idea really is that if there was an exception, then even in that case, I want to make sure that the resource is being closed properly, and that is our responsibility in here. So we are implementing the finally block, and then we are saying if there was an exception or not, I want to make sure the resource is being closed properly, and that is our responsibility to do so in this case. This reminds me of an experience. I was called on a project, and they said go ahead and code review, and while you're reviewing the code, maybe you can find out why we are having problem with the application. I went around asking programmers what the problem was, and one programmer explained it the best. The programmer said, our program works fine most of the time. Well, I asked when it doesn't work, and they said it doesn't work between 7:15 and 9 in the morning. I was like quite puzzled. I said, wow, that's interesting, every day. And they said, oh no, only Monday through Friday. It works fine Saturday and Sunday. So that really was a little puzzling to find out why that would fail only during the time. Well, it turned out to be a portal application with a large number of users logging in during that time, and it turned out that they had an external resource they were using in their application object, and because this resource was limited, there was a problem in creating these resources. Well, unfortunately, they had written the finalize method, and in the finalize method, they had requested the object to be cleaned up, and these objects were fairly short-lived, but unfortunately, because these objects were relatively small, you could have thousands and thousands of objects in memory even before the garbage collector takes note of and decides to garbage collect. So all these objects were created in memory, not being garbage collected for memory. In the meantime, external memory was being accumulated, resource was being accumulated, and those were becoming contentious, exceptions were being thrown, and those were unfortunately not being propagated properly, and so the application was failing, and they didn't know why it was causing the problem. Once we understood what the problem was and figured out what's going on, all we did was ignored the finalize method, wrote a close method, basically issued a request to close the external resource, and then came in here and just called the close method. And as soon as we put the close method, even before we experimented with try and finally, as soon as we put the close method, the problem was gone. They were able to see that the resource allocation and utilization was going down, and it was doing what it was supposed to do, and so that evidently solved the problem right away. So all that we had to do was to write a close method and simply call it. This reminds me of an experience. The boss comes back after lunch in the afternoon, was curious as the boss is supposed to be, and said, how are things going? And the team said, we solved the problem. Well, how did you guys solve the problem? And they said, well, we had to put the close method to solve the problem. And so he was obviously curious, and he whispered, well, if all that you had to write one method, do we still have to pay Venkat? Sure enough, we have to know what the code is doing and what the implications of this are. This is the hard lesson we learn a lot of times. I've fallen through this trap myself a lot of times. I would be writing something and wonder why things don't work properly, and that's because the garbage collection process has simply fooled me. And I've fallen through this trap quite often, as various other developers have fallen through it as well. So the moral of the story really here is it is our responsibility to garbage collect these objects from the resource point of view, and even when there is an exception, we got to make sure that in the finally block we call this properly to close it. Now, as you can see here, there are some limitations of this approach. The very first limitation of this approach is this code now has become more and more verbose. Rather than being a very simple, a couple of lines of code, so notice that the number of lines we really wanted to write here is 2 lines of code. But instead of that, we have gone on to write here quite a bit. 1, and then 2, and then 3 and 4. So that is 4 lines of code for the 2 lines of code we really wanted to write here. Now, sure enough, if you had more things to do here, that little boilerplate code we had to write would begin to reduce. But the point really is, in very simple cases where our goal is really to garbage collect, no matter how many lines of code here, we can still wrap them into a function call and then call as a function. Even in that case, we will begin to realize that there is quite a bit of fluff around this to get this to work. That's the first problem. The second problem is every time we write the code to use our object, we need to make sure we call the code to close the external resources. We got to remember to do that. And remembering to do that requires, in my opinion, sainthood. I am not that smart. I'm not that disciplined. I am going to be forgetting this most of the time. So if I'm on your team, I'm going to forget to do this quite often. And the result is bugs creeping into code and expense and time to be spent to fix these problems. The third problem with this code is that not only do we have to remember to write the close method to clean up the resource properly, we got to remember to put this in the finally block each time. Now you can imagine where this can get really tricky, especially when we're using multiple different objects. We got to make sure to remember to put the close for multiple objects, and chances are we'll forget to put close on one or other object, and bugs can creep in one more time. So in short, the problem with this approach is that this requires a great amount of discipline. It is easy to fail. It is easy to make mistakes in this code, and this is too much of code to write as well. It is very noisy, as you can see here. So how do we solve this problem? Well, thankfully, there are a couple of different ways to solve this problem. We will talk about the so-called automatic resource management in Java. C# has had this for a long time in a using block, but we'll talk about ARM, or automatic resource management, and then after that we'll move on to talk about the so-called execute around method pattern, which is a pattern that gives us an ability to write the code with, I'm not going to say less discipline because that sounds negative. It is a way to write the code in a way that we don't fail or falter so much, where it becomes more natural and the way for us to really write the code becomes much more easier. So we'll talk about an example of using ARM in another presentation, and then we'll move on to talk about the execute around method pattern, which I believe are a better way to solve this problem than putting the responsibility on the hands of programmers and then complaining that they are failing to remember to write this code properly. So we will see that in another presentation.